And we're seeing a universe we've never seen before. We thought it was there, we hoped it was there, but now we see it for the first time since its historic launch in 2021. The James Webb Space Telescope has repeatedly proven itself to be an incredible asset in the search for answers to many of the lingering questions about our universe. Working like a time machine, this powerful telescope has shown us far-off galaxies, the death of stars, and the atmosphere of planets outside our solar system, gifting scientists and all humankind with new breathtaking images from space. Every image is a new discovery, and each will give humanity a view of the universe that we've never seen before. We've discovered the most distant galaxy in the universe, the one that is the furthest away from us that we currently know about. However, the stunning discoveries made by James Webb didn't only surprise the scientific community, it threw them into utter panic. One of Webb's latest findings, simply put, destroys all premier theories of the universe, and that's the most exciting piece of this telescope. This remarkable instrument we put in space is finding things that we didn't expect and that we can't explain, because that means that we have to revise our understanding of the universe. It's not just some abstract scientific problem, it's something that directly affects the future of our galaxy and even Earth. Join us as we dig deep into the newest images of James Webb that caused panic among scientists. The universe resembles a spherical archaeological dig centered on us. The deeper we look into space, the more ancient is the layer that we uncover. Owing to the finite speed of light, we see old images of distant sources that display the way they looked like a light travel time ago. If we allow more time to elapse, we see the same source at a later age, but in addition, when light travels towards us, its wavelength is stretched by the cosmic expansion. Visible light is shifted to the red, experiencing the so-called red shift. As Edwin Hubble realized about a century ago, farther sources recede faster away from us, and so the red shift provides a measure of the recession speed of cosmological sources away from us. We usually consider the red shifts of distant galaxies and other objects as a snapshot of the universe's expansion at a particular time, but in fact they are frames of a very slow-motion film, and we could in principle watch this film roll by waiting long enough. And this is where James Webb really shines. The broad range of infrared wavelengths detectable by James Webb allows it to see galaxies. Hubble never could combine this capability with Webb's enormous mirror and superb pixel resolution, and you have the most powerful time machine in the known universe. 2023 marked the very first full year of science operations for the Webb telescope, and it paid off big, returning the following images and thousands more. The pictures are not just eye candy, they teach astronomers about how stars are born and how they die, how galaxies collide and merge, how massive galactic clusters are created, why some stars which should live for 10 billion years die after only a few thousand and more. In other words, this monster observatory has already brought so many small revolutions to astronomy that picking one from the past year is no small task, and this hard but sweet task will continue in 2024. In just less than 2 weeks since we entered the new year, James Webb has stunned the whole world with its unexpected discoveries. Webb's puzzling findings then raise a series of unanswered questions that make the scientists panic. For quite some time, the prevailing assumption among astrophysicists and cosmologists was that newborn galaxies resembled the familiar orbs and spidery disks found in the present-day universe. However, an examination of fresh imagery from the James Webb Space Telescope challenges this presumption. Contrary to expectations of egg-shaped or disc-like structures, these NENT galaxies take on unconventional forms likened to bananas, pickles, cigars, or even surfboards, offering a diverse array of metaphors. This tentative conclusion stems from a comprehensive review of approximately 4,000 newly formed galaxies observed by Webb during the universe's infancy. This is both a surprising and unexpected result, though there were already hints of it with Hubble, as said Laverge Panda, a postdoctoral fellow at Columbia University. He is the lead author of a paper soon to be published in the Astrophysical Journal under the provocative titles Galaxies Going Bananas. Panda is scheduled to give a talk about his work on Wednesday at a meeting of the American Astronomical Society in New Orleans. If the result holds, astronomers anticipate significant revisions to their comprehension of galaxy formation and evolution. Moreover, it could yield valuable insights into the enigmatic properties of dark matter, an elusive and imperceptible substance believed to constitute a substantial portion of the universe, outweighing atomic matter by a ratio of 5 to 1. Dark matter envelopes galaxies and furnishes the gravitational environments conducive to the birth of new galaxies. In another new stunning observation, the Webb telescope has just detected a massive object larger than Jupiter that appears to be producing infrared emission from methane, in an unexpected discovery by astronomers that could represent evidence of atmospheric heating resulting from auroral processes. The discovery has baffled astronomers because the object, an isolated brown dwarf called W11 1935, is cold and lacks any host star to provide its upper atmosphere with the energy that usually drives such methane emissions. According to new research, it is believed the source of the object's mysterious emissions could arise from processes generating its aurora. Methane emission is commonly associated with gas giants like Jupiter. Heating that occurs in the planet's upper atmosphere is the driving force behind this, and Astronomers believe it is also linked to the vivid aurora that Jupiter and other gas giants often display. Thus, to help explain the mystery of the infrared emission from methane, the team turned to our solar system on Earth. Auroras are created when energetic particles blown into space from the sun are captured by Earth's magnetic field. They cascade down into our atmosphere along magnetic field lines near Earth's poles, colliding with gas molecules and creating eerie dancing curtains of light. Jupiter and Saturn have similar auroral processes that involve interacting with the solar wind, but they also get auroral contributions from nearby active moons like Io for Jupiter and Enceladus for Saturn. 4 isolated brown dwarfs like W1935, the absence of a stellar wind to contribute to the auroral process and explain the extra energy in the upper atmosphere required for the methane emission is a mystery. The team surmises that either unaccounted internal processes like the atmospheric phenomena of Jupiter and Saturn or external interactions with either interstellar plasma or a nearby active moon may help account for the emission. The aurora discovery played out like a detective story. A team led by Jackie Ferry, an astronomer at the American Museum of Natural History in New York, was awarded time with a Webb telescope to investigate 12 cold brown dwarfs. Among those were W1935, an object that was discovered by citizen scientist Dan Castellan, who worked with the Backyard Worlds Planet 9 project, and W2220, an object that was discovered using NASA's Wide Field Infrared Survey Explorer Webb, revealed in exquisite detail that W11-1935 and W2220 appeared to be near clones of each other in composition position. They also shared similar brightness, temperatures, and spectral features of water, ammonia, carbon monoxide, and carbon dioxide. The striking exception was that W11-1935 showed emission from methane as opposed to the anticipated absorption feature that was observed toward W2220. This was seen at a distinct infrared wavelength to which Webb is uniquely sensitive, and we expected to see methane because methane is all over these brown dwarfs, but instead of absor-ing light, we saw just the opposite. The methane was glowing. My first thought was, what the heck, why is methane emission coming out of this object, said FTI. The team used computer models to infer what might be behind the emission. The modeling work showed that W2220 had an expected distribution of energy throughout the atmosphere, getting cooler with increasing altitude. W1935, on the other hand, had a surprising result. The best model favored a temperature inversion where the atmosphere got warmer with increasing altitude, according to Ben Birmingham, a co-author from the University of Hertfordshire in England and lead modeler on the work. This temperature inversion is really puzzling. We have seen this kind of phenomenon in planets with a nearby star that can heat the stratosphere, but seeing it in an object with no obvious external heat source is wild. For clues, the team looked in our own backyard to the planets of our solar system. The gas giant planets can serve as proxies for what is seen going on more than 40 light-years away in the atmosphere of W1935. The team realized that temperature inversions are prominent in planets like Jupiter and Saturn. There is still ongoing work to understand the causes of their stratospheric heating, but leading theories for the solar system involve external heating by aurora and internal energy transport from deeper in the atmosphere. But it's worth noting that this is not the first time an aurora has been used to explain a brown dwarf observation. Astronomers have detected radio emission coming from several warmer brown dwarfs and invoked aurora as the most likely explanation. Searches were conducted with ground-based telescopes like the Keck Observatory for infrared signatures from these radio-emitting brown dwarfs to further characterize the phenomenon, but were inconclusive. W11-1935 is the first auroral candidate outside the solar system with a signature of methane emission. It's also the coldest auroral candidate outside our solar system, with an effective temperature of about 400 degrees Fahrenheit, about 600 degrees Fahrenheit. Warmer than Jupiter in our solar system, the solar wind is a primary contributor to auroral processes with active moons like Io and Enceladus playing a role for planets like Jupiter and Saturn, respectively. Brown dwarfs, though, have no obvious stellar wind source and likely lack volcanic moons, which makes this discovery so puzzling. The brown dwarf's extreme age rules out internal heat leftover from formation as the source of methane emission, which is, the more we learned, the more we wanted to know. This is how science keeps our curiosity alive, but at the same time, the more we discover, the more we panic. Further added, the discovery, though surprising, presents an unprecedented opportunity for astronomers to refine their models of atmospheric and auroral processes. It's a testament to the power of the James Webb Space Telescope to uncover unexpected phenomena in the depths of space and challenge existing assumptions. The James Webb Space Telescope, JWST, since its launch in 2021, has not only revolutionized our understanding of the universe, but has also sparked a new era of exploration and discovery. Positioned at the second Lagrange point, L2, approximately 1.5 million kilometers from Earth, JWST is equipped with advanced instruments that enable it to observe the universe in infrared wavelengths with unprecedented sensitivity and resolution. One of the primary goals of JWST is to peer back in time to the early universe, shortly after the Big Bang, to observe the formation of the first galaxies and stars. By detecting infrared light, JWST can penetrate cosmic dust clouds that obscure visible light, allowing astronomers to study celestial objects that are otherwise hidden from view. This capability has already led to significant discoveries, including the identification of ancient galaxies that formed less than 1 billion years after the Big Bang. The telescope's large, segmented primary mirror, spanning 6.5 meters in diameter, collects faint infrared radiation from distant objects, which is then analyzed by its suite of scientific instruments. These instruments include the Near-Infrared Camera, NIR-CAM, Near-Infrared Spectrograph, NIR-SPEC, Mid-Infrared Instrument, MIRI, and Fine Guidance Sensor / Near-Infrared Imager and Slitless Spectrograph, FGS / NIRIS, each designed to capture different aspects of celestial phenomena with unparalleled precision. In addition to studying distant galaxies, JWST has provided unprecedented insights into the life cycle of stars within our own Milky Way galaxy. By observing stellar nurseries, regions where new stars are born from collapsing clouds of gas and dust, JWST has revealed the intricate processes involved in star formation. This includes the formation of protostars, young stars surrounded by dusty disks of material from which planets may eventually form. Moreover, JWST's observations of stellar deaths, such as supernovae explosions, have shed light on the cataclysmic events that shape galaxies and distribute elements crucial for life throughout the universe. These observations are crucial for understanding the cosmic chemical evolution and the origins of heavy elements, including those essential for the formation of planets and potentially life itself. Beyond star formation and stellar evolution, JWST has also made significant strides in exoplanet research. By detecting the faint infrared light emitted by exoplanets, JWST can analyze their atmospheres and potentially identify signs of habitability or even the presence of life-supporting conditions. This capability positions JWST as a cornerstone in the search for potentially habitable exoplanets beyond our solar system. One of JWST's notable achievements is its ability to study the atmospheres of exoplanets in great detail, using a technique known as transmission spectroscopy. By observing how a planet's atmosphere filters starlight as it passes through during transit, JWST can identify the chemical composition of the atmosphere and search for biomarkers, signatures of life such as water vapor, methane, and oxygen. In 2023, JWST completed its first full year of scientific operations, during which it delivered a wealth of data that continues to be analyzed by astronomers worldwide. The telescope's capabilities have exceeded expectations, providing insights into the universe's early history and paving the way for future discoveries. Looking ahead, JWST will continue to explore a diverse range of astronomical phenomena, from the formation of the first galaxies to the characterization of exoplanet atmospheres. Its observations will not only deepen our understanding of the cosmos, but also inspire new questions and hypotheses about the nature of the universe and our place within it. The scientific community eagerly anticipates JWST's ongoing discoveries and the potential for groundbreaking insights into fundamental questions about the origins of galaxies, stars, and planetary systems. With its unprecedented sensitivity and advanced technology, JWST promises to reveal more about the universe's mysteries than ever before. In conclusion, the James Webb Space Telescope stands at the forefront of modern astrophysics, poised to unravel the complexities of the universe with unparalleled clarity and precision. Its observations continue to redefine our understanding of cosmic evolution, from the earliest moments after the Big Bang to the present-day dynamics of galaxies and planetary systems. As JWST continues to capture breathtaking images and gather groundbreaking data, it reinforces its status as humanity's most advanced window into the cosmos, offering a glimpse into the vastness and beauty of the universe and sparking curiosity and wonder among scientists and the general public alike.